Alright, so a couple of things before we get going here. I think I might have posted, I was tentatively thinking or mentioned I might have office hours this Friday. I actually have to leave in the afternoon, so I'll be here from like 10 to 1:30 if you want to kind of schedule time to meet with me then. I'll be around tomorrow, 10 to 1:30 available to kind of meet. If you have any last minute questions, because what's due at the end of the day tomorrow? Quiz and problem set, right? So before we get started, and I'll update this file when I get back to my office. I hadn't had anybody ask me about it until now. There's definitely what could be a confusing typo in question 7. So I asked you about what percent increase would cause the sale price to increase by 1,000. The actual value is negative there. So what I should have said there is what would cause it to change by 1,000. So you're still thinking about what change would you need to get it to be $1,000 change. So instead of increase, you can read that as decrease. I'll probably update it to just say, what would you need in order for it to change it by 1,000? That way the sign really shouldn't matter. But if that was kind of causing any confusion, I want to make sure I mentioned that. I'll get that file updated when I get back to my office after class today. Also, one thing we didn't explicitly go over, and I think we'll have time to talk about it today, is question 4. So I'll kind of cover something today that we didn't exactly explicitly go through this in class, but things that we talked about and things we've talked about prior to really the actually exam 1. You should have all the tools you need to answer this question, but I'll go through something a little bit more explicit today to kind of give you an idea, and I'll mention when I go through it that it would kind of relate to this question 4. Okay. Some of you, like I said, might have already figured it out. We did kind of talk about it, but I didn't show you explicitly how we would work through it. So we are today going to talk about, we've talked about interaction terms with dummy variables, dummy and continuous variables. Where are we at? Right here. So I'm kind of preaching the choir here as well, but since I'm posting this, I have to mention, I know there's a lot more people that are here today. So I know that these videos, I typically get them posted. Not all, I don't think I've posted one from Tuesday yet, but I try to get them posted. They're good, like semi-replacements for class. But leading into that final, I gave you an extra credit assignment on the midterm. There's no time for me to do that on the final, right? So we need to make sure that we're kind of keeping up to date with this material. It only gets harder. So seeing me work through more examples, I do a lot of work. You'll see today, I'm going to write a lot of stuff out up here that doesn't get captured in the video. Now, next Thursday's class, I likely will be in the hospital. So I mentioned I'll post a replacement video for class on that, and I'll post an announcement when I do that next week, once I'm for sure, because I won't be here on Thursday. But that one I will kind of have the work that I'm doing on a dot cam. So that will be like more of a perfect replacement for what we would typically have in a class. But day to day, when we're in class, you're not going to get anything I'm writing up here. A lot of times that stuff is important to even make sense of some of the other things that we then do on the screen. Okay. So I'm talking to the wrong people here. This is for the people that are going to listen to this probably after the fact that didn't show up today. So let's kind of dive into it here. We might be able to get you out of here a little bit early today. So we've talked about interacting dummy variables. We've talked about interacting a dummy with a continuous variable. Today, we're going to talk just about interacting a continuous with a continuous variable. So let's say I have two variables, x1, x2. They're both continuous, right? So I might think, for example, something like maybe y is whether or not I'm unemployed, and x1 and x2 are my income and my level of education, right? Well, maybe having a higher income makes it such that the effect of having a higher education doesn't change my probability of being unemployed as much, because if I have higher income, I might be able to I might be able to sit out of the workforce a little bit longer. And if I have a higher education, maybe I don't mind doing that because I know I can find a job right away. Whereas if I have a lower education, right, maybe I want to make sure I'm back in looking for a job quicker. So there could be this interaction between these two variables in terms of how they relate to our dependent y variable. So just like we've been talking about, if I want to think about, okay, what's the marginal effect of each of these variables changing now? So the interpretation is not as easy as it was when we had these nice, just simple linear regressions. Because before we could have just said, oh yeah, x goes up by 1 unit, y goes up by whatever beta 1 is. Well, now the marginal effect, right, the change, just like we do marginal cost, it's the change in total cost over a change in quantity. Here I've got a function how is it changing when x1 changes? Well, when x1 changes by 1 unit, y will go up or down by beta 1. But now I've got this additional effect. So if I take a derivative in respect to this, or of this in respect to x1, I'll have plus beta 3 times x2. Okay? So my marginal effect of this first variable will not only include the coefficient associated with that variable, but also an additional component with how that variable x1 is related to this other variable x2 that I've created this interaction between. Okay? So my marginal effect is no longer one value. With all the simple linear regression stuff, we don't think about like the nonlinear. It was always just beta 1, right? Now it's going to be the marginal effect depends on the value of the other variable I interacted it with. So the marginal effect of, say, income will vary depending on the level of education that the person has. And then, excuse me, same kind of thing. What's the marginal effect of x2? What's the change in y from a change in x2? So it's a derivative. So if I take a derivative of y in respect to x2, what am I left with? Beta 2 plus beta 3 times x1. Now the marginal effect of that second variable, no, not beta 1. Copy and paste it here. There we go. Is going, okay. There we go. Is going to be the coefficient on x2, but now also it's dependent on the value of this other variable I interacted with. So now the effect of one more year of education will be dependent on what my level of income was. Okay? So our marginal effects aren't as easy now. Any questions over getting anything here before we actually put some variables to this? So it might make a little bit more sense once we start putting some variables. So here I've got this happiness data set. I think we've looked at it before. I'm going to kind of use it for slides here today, and then we'll kind of look at it a little bit in Stata before we jump to a different data set. But happiness is just this like self-reported happiness measure from 0 to 100, age, hours worked, and then I included an interaction between the two. Right? So my thought process was, as I get older or as I work more, working more means more income. As I get older, maybe I'm a little bit less or maybe more pessimistic about life, or maybe I appreciate the finer things. But then also as I get older, if I'm working 80 hours a week, maybe being another year older doesn't make me as happy, right? So there might be some interaction between the two. So I went ahead in Stata and I ran this very basic regression. Now, when we're interacting dummy variables, they were just 1, 0. When we use this kind of double hashtag or pound sign method, we didn't have to put a C dot in front of it because it was just a categorical variable, right? I think I even showed you can do the interaction with like multiple, like if I had, what was the example we did? I think it was every single type of race of the driver interacted with every single type of race with the officer. So there I wasn't using the C dot command. It treated it as a categorical variable and like included a dummy for every single possible response for that variable. Here, using the C dot command, I'm telling Stata, these are two continuous variables. I simply want you to interact those two variables with each other. Okay? I could generate this by hand by simply creating a new variable where I take age, multiply it by hours worked. That's all it's going to do. So it's going to include both age, that continuous variable, hours worked, the second continuous variable, but also the interaction between the two. Okay? Now, this isn't a perfect example, because if I was thinking about, should I be using this model, or should I be using a model where I don't include the interaction term? What's one thing maybe you could guess here that's going to suggest I shouldn't include the interaction term? So if I look at that coefficient, what's true about the interaction term's statistical significance? Its p-value is 0.13, so it's not quite statistically significant, right? So that would be one indicator that suggests we shouldn't be including this interaction term. It might not be capturing the relationship between age, hours worked, and happiness, as well as just simply including age and hours worked. Now, if I had a second regression where I didn't include the interaction term, what's one thing you might think I want to compare between the two to tell me if I should be, if that interaction term model is better? We did it for nonlinear stuff. So what else could I compare? So if I have two models, Yeah, adjusted, right? Now, why don't I want to use the R squared? Because I'm including another variable here with the interaction term. So of course R squared is going to be higher. So I want to compare the adjusted R squared. So the same sort of principles that we talked about with like quadratic or nonlinear models, the same thing would apply here when we're including interaction terms. Okay. In fact, a lot of the things will kind of be very similar. So I've got my coefficient or the effect of being 1 year older, but I also have the effect of being 1 year older. There's an additional effect that depends on how many hours I'm working. And as I work more hours, the effect of being 1 year older is actually going to be lower, right? It's a negative coefficient. So we're going to start thinking about what these marginal effects are. So what do I have here? Do I have the, yeah. So let's say, what's the marginal effect of being 1 year older here? Well, I take a derivative of this y variable, happiness, in respect to the thing that's changing, age. I'm left with beta 1 plus beta 3 times my hours worked. So just to kind of give a visual of this, we had happiness as a function of age. I'm going to just say HW for hours worked. And then an interaction between the two. Okay. So when I looked at the actual regression results, I showed them to you. This was 0.0946. This was negative 0.0012. Oops, 2. So what I'm thinking about now is what is the marginal effect of age? Well, we said in general it was this beta 1 plus beta 3 times the other variable, or 0.0946 minus 0.0012 times that hours worked variable. So what I'm now thinking about, if I wanted to know what my marginal effect of age is, right, it's going to depend on the number of hours worked, right? As that number of hours worked changes, my marginal effect of age is going to change. So if my hours worked was 0, what would the marginal effect of age be here? Well, simply, well, if this is 0, 0.0946, or just that coefficient on the non-interaction term. That's kind of where that marginal effect of age is going to start out if the variable I interacted it with was equal to 0. Now we know hours worked, well, I guess could be 0 when these people are unemployed, right? It's not the most likely thing we're going to make predictions for. So what's going to happen to that marginal effect as I increase hours worked? It's getting smaller, right? I'm multiplying a negative value by a larger and larger. It's going to be decreasing. Okay? So my marginal effect of age is no longer one single value. It depends on this other value, hours worked, right? I've had a couple classes already, so I'm getting burned out a little bit, so I need a break. So we have this marginal effect that's decreasing. What we are going to be interested in, and we can talk about ways of solving, what's happening at this point? The marginal effect is equal to 0, or it's going from becoming positive to negative. Well, if I'm thinking about trying to predict things, or if I'm wanting to change something, I'm like, oh, well, being 1 year older, that's going to make someone happier, right? The marginal effect is positive. Well, only if they're working a number of hours below this point. After that, being 1 year older, if they're working this many hours, being 1 year older is actually going to have a negative impact on their happiness. Okay? So I might be concerned in a lot of these examples was where that turning point is. We'll have a second example that once we get through the slides, I'll go through and state it that I think is a little more practical, or I shouldn't say practical, a little more interesting. Yeah. So how could I figure out where that point is? So I'm going to jump the gun a little bit. If you're kind of having the slides pulled up, we're going a little bit out of order, but I think it makes sense to do it. Right? So how would I find there we go. Right? How would I find where that turning point is? Well, if I know the marginal effect, in general, was beta 1 plus beta 3 times hours worked. How could I figure out where the turning point is? That's going to be when the marginal effect is equal to. So if I have this, I now have an equation. I can solve for what that hours worked would be. So a little bit of algebra here. I get that the hours worked is going to be negative whatever the coefficient on the non-interaction term was for the variable that we're looking at, divided by the coefficient of the interaction term. Now, this turning point, right, here all I have to do is simply plug in these two coefficients, right? So I had what? 0.0946 and negative 0.0012. So I'm going to cheat. I think approximately this is like, we'll see. I do it later on. I think it's 78 or somewhere in the 70s, right? So what that's telling me is that being a year older, as long as I'm working fewer than 78 hours a week, I'm generally happier, right? Maybe I'm just fortunate to be alive, right? But if I start working 80 hours a week, maybe I'm driving a truck, being another year older just means I've got to work another 80-hour work week every single week. And maybe I generally don't have as much, it's actually decreasing my happiness, right? That I could somehow work fewer hours, being a year older would actually make me more happy, okay? So we can find these turning points simply by using that ratio of the non-interaction term to the interaction term. Now you'll notice here, what has to be true in order for me to have a turning point that would make sense here? So because there's this negative sign out front, what would happen if both of my coefficients were positive? Then the turning point for hours worked would actually be a negative value. Can I work negative hours? No, right? I've got an example later on that we'll look at where we see that sometimes these turning points don't exist, right? And sometimes they are a bit egregious, right? There are people out there that are working 78 hours a week, but there's not a lot, right? So for most people, being a year older generally is going to make them happier here. Now, if we're looking at people who do go past that point, being a year older is actually going to make them less happy. So that marginal effect is dependent on the other variable I interacted this variable with. Okay. Any questions on this idea before we keep moving? Now, if you wanted to every single time, instead of like thinking about it this way, you could just plug in what these values are, set it equal to 0, and do the algebra every single time. If you do, it's always going to be that ratio though. Okay. We okay with this before we keep moving? All right, so that's not what I wanted. There we go. So we're going to take these coefficients, right? Then what's the marginal effect? Well, we might not want to find the turning point. If we know that for most hours worked, it was a positive effect, maybe I just want to come up with what's the marginal effect at different hours worked. Well, there I've got that general marginal effect equation. I just plug in my coefficients and I can start to come up with what the marginal effect is at different values for the other variable. So at 30 hours worked, being a year older, increases my happiness by about 0.05. If I'm working 60 hours a week, being another year older would only increase it by 0.02. Okay. Any questions on that? And you can make, if you wanted to, prediction for every single age or every single hour's work if you really wanted to, right? And I'll show you a way of doing this in Stata later on in class. So what if I had the same regression, right? So same results, but now I'm interested in, well, what's the effect of another hour worked? Well, now I'm not going to be using the coefficient on age and the interaction term. I'm going to be using the coefficient on hours worked in my interaction term. Okay? So it becomes very similar, right? I've got the same regression equation, but now if I want the marginal effect of working one more hour, now I'm taking a derivative of that function, that y variable happiness, right? That's all we're doing with linear regression. You think of why this would line up a lot with economics, because a lot of times we're trying to predict, well, output is a function of labor, capital, natural resources, whatever we want to differentiate, skilled, unskilled labor. What is GDP? It's a measure of, consumption, that go down the list, break down all these different categories. That's all we're doing with linear regression, right? Happiness is a function of these two variables. Not only is it just the linear term though, we've now included this interaction. So the marginal effect of 1 more hour worked would be what? Beta 2 plus beta 3 times H. So now the marginal effect of 1 more hour worked depends on how old the individual is. Okay? So as soon as we include this interaction term, the marginal effect of both variables will depend on the other. Right? When we determine the marginal effect of each variable, it'll be a function of the other variable. Okay? So I can do the exact same thing here. Right? If I go back, what was my coefficient on hours worked? 0.1002. Interaction term, negative 0.00125. I could then use those coefficients for my marginal effect and make predictions for what's the effect of 1 more hour worked for people of different ages. Here I chose 22 versus 60, right? So working 1 more hour when you're 22, you know, we're not controlling for income. So my guess is what's driving this. When you're 22, working another hour gives you pretty good % increase in your income, right? You don't have a huge amount of money saved up. So it makes you quite a bit more happy. If I'm, 60 years old, working another hour, I've already got some savings, right? More money is always better, but I mean, I'm also 60, I need a break, right? So it makes me happier, but not as large of an effect, right? So our marginal effect here depends on the other variable. Okay? Any questions on that before we keep moving here? So I kind of already alluded to this earlier, but here is kind of in general form. If I've got a marginal effect of a variable, so here the marginal effect of x1 would be beta 1 plus beta 3 times the other variable. And I'll put this in the context of our happiness example in a second. Well, I could take that marginal effect, set it equal to 0, and we said figure out where that turning point is. So for us, if I want to know what's the turning point for that second variable, right? It's going to be the coefficient on the non-interaction term divided by the coefficient on the interaction term with a negative sign out front. So let's look at I already mentioned this as well, but this is a good thing to mention again. Not only if both coefficients are positive, might there not be a turning point. If they're both negative, right, there might not be a turning point. And we'll walk through some examples where that exists, right? But for now, right, let's look at this, okay? So where's the turning point of my age variable? This was the one that we walked through earlier. We said, okay, take a derivative of this function with respect to age. I get beta 1 plus beta 3 times hours worked. Set that equal to 0, rearrange it a little bit, plug in my coefficients I got from running the regression. I was a little off. I said 78 earlier. I think I was rounding my decimals there. So it's about 75, right? So anything past 75 years old, the marginal effect of being anything past 75 hours worked, the marginal effect of being 1 year older was actually going to go from positive to being negative. Right? That was kind of our visual that we had. Any questions on this? So what if instead we've got our regression equation? What if I wanted to know what's the turning point for the marginal effect of hours worked? Well, we said that would be beta 2 plus beta 3 times h, right? Taking a derivative of this with respect to hours worked. I can plug in the values here. I think this was like 0.100. See if I can get this pulled up so I'm actually giving you the right values here. Rounded to the 4th decimal, 0.3. This was negative 0.0012, right? So we could set this equal to 0, do the algebra, or what will always be true is our turning point for the marginal effect of hours worked will be the value of the other variable age and that negative coefficient on the non-interaction term divided by the coefficient on the interaction term. Right? Same kind of setup, it's just looking at the other variable. So here, I have what? Negative 0.1003 divided by negative 0.0012. This is going to be approximately, I'm going to cheat. Can't do this in my head. What, 80-ish, right? 80.24, I think is going to be the same exact value. So when I'm thinking about the marginal effect here, of hours worked, it's going to start out when age is 0. It's starting out at what, 0.1003. But then as someone gets older, what's happening to that marginal effect? Well, I'm multiplying this negative coefficient by a larger value. It's decreasing. So that turning point where the marginal effect goes from being positive to negative is approximately at an age of 80. So, oh, sorry. There we go. So we can solve for these turning points or where that marginal effect goes from being positive to negative, right? And it's simply that ratio of our coefficients. Okay. Questions on this? All right, let me think what I want to do next. So I have this basically the same thing in the slides, but I want to make another point, which is this is simply talking about marginal effects. If I'm just concerned with making predictions, I can still make predictions for happiness based off of my regression results, right? So let's say I want to predict not the marginal effects, right? That's what we're doing over here. It's the marginal effect of one being 1 year older, marginal effect of being, working 1 more hour. We can also simply make predictions for what happiness will be. So I think this was, kind of grab these values, 67.7. This was 0.0946, 0.1003, negative 0.0012. So let's say I want to make predictions for happiness for someone who's 30 years old and they're working, I don't know, 50 hours a week. It's just like we were making predictions before. I'll take those coefficient values and just plug in my hypothetical values, right? So take the intercept, add the coefficient on age times 30, add to that the coefficient hours worked times 50. Now for the interaction term, I will then add in, well here I'm subtracting because it's a negative coefficient, but I'll need to make sure that I'm multiplying both of those hypothetical x values by each other. Right? It's really just a long linear equation, right? And I'm just plugging in this hypothetical person I'm wanting to make the predictions for. Okay? But what this allows for is it allows for the effect of both of these variables. If we think that they're somehow related, we're capturing that now. Okay? Any questions on this? Keep moving here. Okay. Making sense? Okay with this? Something before we go to a second example, I just want to point out. Well, I'll hold up on that. Let's do one more thing and we'll kind of come back here. So I think I reposted this interaction terms fall 2024 file. We did all this mate height stuff last class. Here was kind of that basic regression that I was running. I was showing you age and hours worked. Let's look at one where I'm doing the same thing, but I've got the number of children and hours worked, right? Maybe I think there's some interaction between the two. Okay. Now, I could run this model. So I'm going to run this model, but I'm also going to kind of show you something. Run the one where I just treat it as though there's no interaction between the two. So when I run these two regressions, what this will do is it'll include children, it'll include hours worked, and the interaction between the two. So what should be happening to my R squared? If I'm adding essentially another variable, it should be going up. Okay. And if I didn't break stated here, I'll kind of show that to you in just a second. All right. We're waiting. Keep hitting save here. There we go. So, oh, guess it would help if I open up the data. So let's open up happiness. It was one of the files on the home page there under week 10, 11. So I run this regression. I see the model without my interaction term. Well, my R squared is pretty low. Looks like I've got a lot of omitted variables here, right? But my R squared went from 0.0015. It looks like it didn't change at all. Now, we know that if we could look out to the fourth or fifth, sixth decimal, it did have to go up somewhat, right? So what should I really be comparing is my adjusted R squared. My adjusted R squared actually was lower from the model where I include the interaction term. So that's one indicator that I shouldn't be. There isn't this interaction relationship between these two variables. Also, the coefficient on my interaction term is like a p-value of 0.7. I can't say this is statistically significant at like any reasonable level. So it appears here in this second regression that there really isn't an interaction, that the marginal effect of having another child or hours worked, really they don't depend on each other. Right? I would have both the things. The adjusted R squared was higher, or sorry, the adjusted R squared was lower, and I don't have statistical significance on that coefficient of the interaction term. Right? So that's the kind of two things we would look at that would suggest that we should be using the interaction term, and both suggest we shouldn't be. Is that clear what I'm getting at there? Okay. However, let's just assume it was, just for a second, right? So I've got my coefficients on the two terms. I've also got my coefficient on the interaction term. So if I was writing this out, I've got happiness as a function of hours worked. I'm just going to say kids instead of children, just to save myself a little bit of room. Thank you. So just writing out what that regression equation would look like. Okay. So if I wanted to know the marginal effect of having one more kid, right, I would say, okay, what's the derivative of happiness, this regression equation, in respect to that variable that I want to know the marginal effect of, the thing that's changing? So it'd be beta 2 plus beta 3 times hours worked. Okay. So if I'm plotting this out, I'm thinking about the marginal effect of having one more kid, right? This coefficient from my regression results was 0.008. I'm rounding pretty egregiously here. And then 0.00006. So I know that if this was statistically significant, then the marginal effect of the variable that I interacted with the other variable, so kids, should depend on that variable I interacted it with. Sure enough, my marginal effect of kids is a function of hours worked. It depends on. If hours worked was 0, what's the marginal effect of having one more child? 0.008 here. As the hours worked increases, what's happening to my marginal effect? Well, if this is a positive value, it's increasing, right? So this would be an example where if I tried to find my turning point, we said, what's the kind of general, how do we find kind of this turning point? Well, it's going to be the coefficient on the non-interaction term with a negative sign out front, divided by the coefficient on the interaction term. Well, here, 0.006 divided by 0.00006, know exactly, we don't really care what that is because it's going to be some negative value. Both of these were positive, so the turning point here has to be somewhere down here to negative value. Right? Well, we can't ever see hours worked be negative, right? So this would be an example where a lot of the times a real what word am I looking for here? Not, I guess applicable, but there's a better word. But the turning point may not be something that's usable, right? Because it just doesn't exist. We can't have negative hours worked. So anytime you have coefficients that are the same sign, we're going to end up with a negative turning point, which for most of our variables doesn't make sense, right? Now, if we have something that has positive and negative values, for instance, maybe we have something like profits, Well, there we can see negative profits. There could be a turning point of negative profits where we see, I don't know what the relationship would be, but that actually makes sense to have a negative turning point there. Okay. But for most variables, we would, they're usually positive values. We would want a turning point that's positive. If that doesn't exist, really, the marginal effect here of having another child for any hours worked is going to be positive, right? In fact, it's kind of weird. The more hours I work, the effect of having a kid actually makes, has an even larger impact on happiness here. Now, once again, we've got a lot of important omitted variables. Right? So, are you with me at least up into this idea of the turning point? So this is something I wouldn't quite tell you what I'll expect you to know, and then I'll show you a little bit more, right? So let's say I were to estimate this relationship and everything's statistically significant. What could be true is that when I'm looking at the estimate on just kids and then the estimate on the interaction term, if I've got a lot of important omitted variables, we can go back to our omitted variable bias, right? The omitted variable bias says, I will have, when I estimate the effect of this variable kids, it'll be the true effect plus, I'll call this the coefficient on this important omitted variable times the covariance between this variable I'm looking at and the omitted variable divided by the variance of this variable I was looking at. Now, if I do the same thing for my interaction term, it'll include the true interaction effect between hours worked and kids, but it'll also include what the effect of this important omitted variable would have been, and now multiply that by the covariance between, well, what variable am I estimating the relationship? Now I'm looking at the interaction term. So it's the covariance between hours worked times kids and the omitted variable divided by the variance of hours worked times kids, right? So that covariance might be very different, right? That bias, these are not, quite the exact same equation here, right? And so my bias here in my interaction term may be different than the bias that exists in that non-interaction term. So what becomes important when I think about omitted variables for interaction terms is that, well, maybe that beta 3 estimate I see, maybe the interaction term looks like the effect is 0. But in fact, the effect is much larger. It's just that it contains a large bias. So if we have important omitted variables, it can lead us to thinking that there is no interaction between this variable of children and hours worked or hours worked and age, when in fact there is, right? It just kind of depends what those important omitted variables are, what impact they would have had if we included them in the regression, and what the relationship was, not just with that variable kids, but the relationship between the interaction between kids and hours worked, right? So I won't ever expect you to kind of put a sign to this or ask you to kind of calculate this on a homework problem. But just know that the omitted variable bias can cause us to see that the interaction terms may not, it may look like there is no effect, there's no, the coefficient looks like it's 0 on the interaction term when in fact it could be much larger or much smaller, right? It could be a much larger negative value, right? Because we still have that omitted variable bias that could exist, even for interaction terms. Okay. Any questions on this? So something related that relates to problem 4 on that homework set I told you I'd tell you about. The same kind of thing happens when I'm looking at nonlinear relationships. And there I did ask you to do it. This one gets a little bit trickier since you're looking at multiply, but here let's think about I don't even remember what it is. I can kind of give you a good, it was price of the car. I think it was kilometers driven. And then kilometers driven squared and a bunch of other controls, right? So when you're thinking about what bias might exist in both the linear and nonlinear term, So let's say I had this important omitted variable, and I think it was. I have it pulled up here. What was it? Whether the car was manual. Does that sound right? Hold on. Pull it up here. Help me out quite a bit. So, wait. Never mind. That's not at all problem 4 in the problem set. It was earnings. And here we had age, right? Is what we were thinking about. So age and age squared. Bunch of other controls. And our kind of omitted variable was whether or not the individual was married. Yes. So if we're thinking about the estimates that we see when that omitted variable is left out, we're going to get the true effect of age here, or the linear component of it. But we're also going to get what the effect, I guess I could write here, what the effect of that omitted variable would have been, okay, multiplied by the covariance between age, married, and then over the variance of the variable we included, which was age. So I think I asked you to use the, calculate the size of the bias using covariances. So you would run this, since I think you have the married variable in your data set, you would run it with married so that you could obtain what the coefficient on married would have been if you could include it in your data set. Okay. You can then use the covariance command to see what the covariance between age and married was, the variance. You could then calculate the size of the bias. Now it gets a little bit trickier. Right? Is what about the squared term? Well, there I'll pick up the true kind of nonlinear relationship on that square term, or what that coefficient should be. But I'm also going to pick up the effect of the omitted variable, excuse me, times the covariance between, well, now my variable isn't age on this coefficient, it is age squared. Right? So it's going to be the covariance between age squared and married divided by the variance on age squared. So I'm going to, I can create this new variable, age squared, by simply taking age times age. I could then use that correlate kind of covariance command to figure out what the covariance is between age squared and married. And what might be the case is that that covariance between age squared and married is different than the covariance between age and married. So I might end up with, someone asked me, I think in my last section that I was telling about this, like, well, I find different values. Probably. Right? A lot of the times, these omitted variables, they'll have a very different relationship with the linear term than they will with the squared. So you can kind of calculate what the size of the biases in both of those coefficients the same way we were doing before. Right? This is the same thing we were doing with just a very simple linear term and one omitted variable. It's just now you're looking at, well, what's the bias created if the variable is squared. So just a little bit different there. Okay. Questions on? All right. So in general, when it comes to the interaction terms, I won't kind of make you go through all of this. You can do it with the square terms relatively easily. I just want us to know that when we have these omitted variables, they can cause us to find very different biases in the coefficients on the non-interaction and the interaction term, very different biases in the linear and the nonlinear term. Okay. Any other questions here before we keep moving? It actually gets you can complicate this even a little bit more if you want to, but this is what we can do here. Where are we at in time? So 30 minutes. Let's make sure we get through this other example. If we have time, I'll mention something that kind of pushes us past what I would expect you to know. But since I'm not going to expect you to know, I don't want to kind of waste time if we're not going to have it. Okay. So I also put up on the home page here this election 2020 data and this interaction view file. So let's dive into data here. Got these election interactions. So I think it's an Excel file, so I'm going to import this Excel file. 2020 data, first row are variable names, hit OK, clear out my data. So here it says percent that voted for Trump, but clearly this data is in proportions, right? And I've got a bunch of other variables in here. I had some like COVID stuff and I can play around with that in a different class. What I wanted to focus on here, I'm going to first just create a new variable so that I'm converting that proportion into a percentage just because it's easier to talk in percentages. I'm also going to scale my income variable. You'll see why in a second. Just originally what I want to show you, it makes the coefficient a little bit easier to deal with. So I'm going to scale it by 1,000, making it represent not just dollars, but thousands of dollars. So I'm going to create those new variables. Now, what I can do here is let me see. Yeah, okay. So I'm going to run this regression where I've got income in thousands and I interact it with unemployment. So my thought was, maybe the percent of people that wanted to vote for the incumbent candidate in 2020, having a higher income matters in a county, but not if the majority of the county is unemployed, right? And so the effect of having a higher average income in a county, it's going to depend on, well, what percent of the people are unemployed? Because to them, their income's zero. They don't care if the average, income of people who are working is higher, they're unemployed, right? So I'm going to include this interaction between the two using that double kind of pound sign hashtag and put C dot in front of both of these continuous variables. So here I look at these results and I've got that, the income and unemployment, they're highly statistically significant. Now here, okay, my p-value, it's not quite statistically significant, right? So that's one indicator that maybe I shouldn't be including that interaction term. But I could also run this same regression. What's another thing that I could kind of look at instead of just the statistical significance on the interaction term? I could compare so I run this regression without the interaction term. What's a statistic I can compare between these two that tells me whether or not I should be including the interaction term? My adjusted R squared. So if I look here, if I run this without the interaction term, my adjusted R squared is 0.4865. Okay, so this is a weird one where, all right, well, the interaction term model, the adjusted R squared is a little bit higher. Not much, but a little bit, right? So here, sometimes these two things will suggest opposite models, right? If it's not completely clear, which is why, my p-value, it's not that far away from 0.1, right? I mean, I could say that this is significant at the 75% confidence level. So here I've got one, okay, I've got some conflicting evidence. So maybe I should be including this interaction term, maybe I shouldn't be, right? For the sake of what we're going to be doing for this example, let's just assume this was 0.02, right? That we found it was statistically significant so that we can use it to kind of think about turning points, okay? So I've got this, this regression where I have the interaction term. Let's put that at the bottom. So let's just run that again. All right. How could I figure out where the turning point or the marginal effect of income is going to be? Well, first of all, will there be a turning point that makes sense? If I've got negative coefficients on the non-interactive terms, positive coefficient on well, they're different signs. We said, okay, now I'm going to end up with a turning point that's positive. That makes sense for income and unemployment. If they were both the same sign, the turning point would be negative. I can't have negative income or negative unemployment. So we know that we're going to have turning points that make sense here. So let's kind of think about what those would be. So if I've got here, I think I'm going to do first marginal effect of, let's do income. So when we had percent that kind of vote for Trump, we had income in the thousands, we had unemployment, and then we had the interaction between the two. So my marginal effective income is going to be beta 1, take a derivative of this function with respect to the thing that's changing, and then plus beta 3 times unemployment. Okay. Well, so if I look at these results, this was negative about 0.37. This was 0.00, kind of rounding egregiously, but 0.007. So where is that turning point going to be? Well, if I think about visually, when I want the marginal effect of income, it's starting out, it depends on the level of unemployment. When unemployment is 0, where would the marginal effect start out at? Actually here, down here at negative 0.37, right? Now, as unemployment actually goes up, what's happening to the marginal effective income? It's also going up. So it seems kind of weird, right? Now we could have omitted variable bias here. Oh, sorry. Let me know if that happens again. Sometimes I need to. There we go. So sometimes we get some weird interpretations because of omitted variable bias, but here, the marginal effect starts out negative, and at some point when unemployment gets high enough, the effect actually becomes positive, right? So having higher levels of income initially for lower levels of unemployment didn't make it more likely that people voted for Trump, but actually made it less likely. So this might be an indicator that wealthier areas sometimes, tend to be, if you're thinking about what's the count, like Orange County, right? They're very, very wealthy, but they probably tend to vote a little bit more towards the left, right? So there's a lot of omitted variables we don't have here that might be capturing that. So where is this turning point going to be? At what level of unemployment will the marginal effect of income actually be positive on the percent of people that in that county that voted for Trump? Well, what did we say? We would set our marginal effect equal to 0. That would give us this, all right? So the unemployment that represents our turning point would be negative, the coefficient on the interaction term, divided by the coefficient on the interaction term. So here we would have negative times negative 0.37 over 0.007. Oh, so this is my unemployment. I forget what this is off the top of my head. We're going to look at it here in a little bit. Oh, let's do what? Anybody want to call me now? So 50. No. Oh, there we go. So we got what? 0.37 divided by 0.007 gives us, oh yeah, 50. I was right on. 52 something. So we'll say approximately, I think, 53. Right? So at an unemployment percentage of 53%, that's where the marginal effect becomes positive. Well, this is a good example of one where, yes, the turning point does exist. You could see 53% unemployment. But in practice, if I look at this data set, there is no county with 53% unemployment. So for every county in this data set, the marginal effect is actually negative. Now, for some counties that have lower unemployment, it's a larger negative value than for those that have higher unemployment. But sometimes these turning points, we can still calculate them, but in practice, like we never actually see the marginal effect switch to the sign, right? We just never see a county at 53% unemployment, or hopefully we don't, right? So we can still calculate where that would be, right? Does that make sense what I'm saying there? All right, so we'll then kind of move on to thinking about what if instead I wanted to kind of use, instead of doing this all by hand, I want to use some things that are kind of built into Stata for us. So here we'll look at the marginal effect of both. I'm going to switch over now. Instead of using this syntax, I was using 1,000, so that gave us like a nice coefficient of 0.007 on the interaction term. What can happen with these interaction terms, especially if you have like things that are measured in really large values like income, and then the change of $1 is relatively small. I think if I run this regression where I just use income and unemployment, and I create the interaction myself. So I'm going to create this new variable. I'm not using the scaled version of income. I'm just using regular income. I'm then going to create the interaction term myself. I'll show you why in a second, as opposed to using this C dot double hashtag method. Notice that coefficient of my interaction term is what? 0.000006. You can make it really small because that unit is relatively small. A $1 increase is pretty small, right? Now, if I'm doing this by hand, now rounding makes a really big difference if I'm rounding out to the 7th or 8th decimal. Now, we can use Stata though, to where we don't have to do this by hand and the rounding doesn't matter, and I don't have to worry about scaling my variables maybe as much as I did before. So when it comes to the problem set, not this one, but the next one, which I'll mention at the end of class before we go. It might be easier to try to do this work in Stata as opposed to doing it by hand. Now you still can. I don't expect that you do have to make this, do a calculation in Stata, but I'll show you how you could. So we've got this regression. I've created the interaction term, a new variable between income and unemployment, because before we were using that C dot, the actual name of the interaction term is like not nice, right? By all means, you can use this and then call the variable this, right? It's easy to forget the hash or the pound sign. It's easy to forget the C dot. I just, out of good practice, I just generally create it myself to make it a lot easier. Also, I can shorten the name quite a bit. So it makes life a little easier. So I'm going to just run that regression where I create that interaction term myself. Apparently, I already created it. Right? And it does have that small coefficient in there, right? However, we talked last class, I think, or the class before, about using this display command, right? So if I want to know the turning points, right, for both of these two variables, unemployment and income. Now, I've included some other controls in here I didn't mention before, but like proportion of the county that was male, different proportion that was just different races, total population. It's not perfect controls. My R squared is still about 0.5, so there's still about half of the things I can't explain, but it's, it's not 0.001 or whatever we were looking at one of the regressions earlier. So what I can do is after I run this regression, we said this underscore B, and then kind of using these brackets, that allows me to use the coefficient that's stored for that variable from the previous regression. So I can only ever use this, it's only ever using whatever the last regression ran was. So my marginal effect here of unemployment, right? Actually, we'll do income first because that's the one that I wrote out for you. The turning point for income here would be if I take a derivative of this function in respect to income. So that would give me the coefficient on income plus the coefficient on the interaction term times whatever the value I interacted it with, which was, well, hold on. Let me write this out for you. So actually, I think I have it right here. So we had sometime today, there we go. Right, it was that coefficient on income plus the coefficient on the interaction term times unemployment. So if we set this equal to 0, we said the turning point for unemployment was going to be that ratio of the coefficient on income divided by the coefficient on the interaction term. Okay, so that's all I'm doing here in this line of code. I'm taking that coefficient on income, dividing it by the coefficient on the interaction term. Now there has to be a negative sign out front, so I made sure I multiplied it by -1. Okay? If I then run this display command, I can be a little bit more precise. I think when I rounded before, it was like 53. The actual precise value is 54. Right? So that kind of turning point on employment would be 54. Okay? Questions on anything kind of there? So once again, I would, for me, it's easier instead of doing this by hand, worrying about rounding to different decimals. I can just use the stored coefficients from that last regression. Now, I can do the exact same thing for unemployment. What would the marginal effect of unemployment be? Well, I kind of wrote it out here since we didn't do it up here, but it would just be the coefficient on unemployment plus the coefficient on the interaction term times the variable I interacted unemployment with, which was income. Okay, well now where does this marginal effect equal zero? I set it equal to zero, and then can figure out what income level will the marginal effect of unemployment go from being positive to negative. In fact, if I look at those coefficients, if income was zero, what does the effect of unemployment start out as? So income is zero, the marginal effect is simply the coefficient on it. So it starts out negative, and then because the interaction term is positive, as income goes up, that marginal effect of unemployment starts to become a smaller and smaller negative value. So I can do the same thing, right? I'm going to solve for that turning point. What income would be the turning point for the marginal effect of unemployment? Well, here's a good example, kind of similar to the unemployment one. Okay. It becomes positive once I get to an income in a county, an average income of 139,000. I mean, maybe Orange County is going to have a positive marginal effect, but for almost every reasonable county in our data set, they're going to have an average income below 139,000. We won't really probably ever reach that turning point, right? So we can still calculate where it is, and that still gives us information, right? Because now when I'm thinking about the marginal effect of unemployment, when unemployment was going up, it was actually having a negative effect on the percent of people voting for Trump. That makes sense, right? If unemployment is going up, we blame the incumbent, right? Now, as the income was higher in that county, the effect was smaller, right? So this is the idea that, yeah, just because unemployment was going up, in an area, if the people that had jobs, things were going really well for, they were kind of locked in to vote for whoever was currently in office, right? Excuse me. So here, even though this turning point likely doesn't exist for any county in our data set, like I said, maybe one of the, maybe one in California or something like that. This tells us that, okay, well then we know that the effect of unemployment for most counties is going to be negative in terms of the percent that voted for Trump. Right? So it still tells us something, even if we won't see that turning point exist in the data. It tells us that the marginal effect will likely always be negative in this case. Okay. Any questions on that before we kind of keep moving here? This is kind of making sense, hopefully. This just gets kind of tricky with these continuous interaction terms. So I put plot here. We're not going to quite plot it. I just wanted to show you something kind of interesting you can do. Kind of, I don't know, cool is in relative term, right? But let's say I go back to running that regression using the syntax of like these C dots. Here's one reason why it doesn't make sense to create your own variables. Here's one thing that would actually be easier to do using this C dot method. So I'm going to run this regression once again, income, unemployment, their interaction term. If I use this margins command, what it will do is essentially what's the marginal effect of income. So dy dx, that looks like derivative. That's what it's doing. So it's going to take a derivative of your linear regression function in respect to whatever variable you tell it. So this is going to tell me this margin. It's going to tell me the marginal effect of income. Now, because I've included an interaction term, I need to tell it, well, the marginal effect is going to vary with this other variable I interacted with, right? Unemployment. So give me the marginal effect of income at all these different levels of unemployment. So starting with 1, unemployment percent of 1, all the way up to 75. See why in a second why I chose to be so high. And do it in increments of 1. So if I run this after I run my regression, it does all the work behind the scenes for me. It'll grab those coefficients on the non-interaction and the interaction term. It'll calculate the marginal effect when unemployment is 1%, 2%, 3%, 4%, 5%, 6%, all the way to the 75th percent, right? I could do more if I wanted to. I guess I would go up to unemployment of 100 if I really wanted to, but that seemed a little overkill. Now, what age did we say the turning point was? Remember, it was right around, I think it was 54 something. Notice at all these different unemployment percentages, the marginal effect, so it starts out really negative, more and more, starts out really negative, getting closer and closer to 0, right? We said it was kind of increasing until we get to 54. It's still negative at 54, but once we get to 55, now the marginal effect is positive. So my turning point there, like I said, it was like 54 point something, right? So going from 54 to 55, we now see, oh yeah, the marginal effect past that turning point. Now the marginal effect of income appears to be positive. Okay. Is that any questions on that? It's not too crazy. It's also like a nice, easy way, like maybe I had, maybe I wanted to make some predictions for like, I'm trying to do some economic consulting. I can very quickly come up with like what the additional or the marginal effect of something would be for like counties of any unemployment really quick. I don't have to just do jumps of 1. I could do jumps of 0.1, right? And now I kind of have this nice table list where I can give to like a client, be like, hey, yeah, you want to know what the effect of, if you increase your ad sales by X number of dollars, well, what is your current, I don't know, maybe the amount you're spending depends on what your current sales rate is or current level of sales is. So you like create these tables to like they could actually figure out, oh, this would be the effect of another dollar spent on advertising given where my current level of sales is, right? So kind of useful. I won't ask you to do something like this on the homework assignment, but it is something that's valuable. And it does get a little tricky, I won't lie. So here I'll show you one where it gets kind of weird. But if I use this margins command, let's say now I try to figure out the marginal effect for unemployment. Well, we know it depends on the variable we interacted it with, which is income. However, making predictions, we know that average income isn't going to be 0, right? But if we look at average incomes, I mean, I think in this data set, 50,000 is a little bit higher than the minimum, but there's not really anything lower than 50,000, right? So let's start out at 50,000 and make predictions for the marginal effect of unemployment for incomes of 50,000 all the way up to 150,000, but we're going to do it in jumps of 10,000. So you can do this. It gets a little bit weird with the output because it treats the iterations, that's the numbers it's actually using. So here, the marginal effect when it has a 1, that's actually saying that's the marginal effect of where you started, 50,000. So the marginal effect of unemployment at an income level of 50,000 is negative 0.61. And then what's the marginal effect of the next step? Well, going up in steps of 10,000, the marginal effect of unemployment at 60,000 would be negative 0.54. Then the marginal effect of 70, 80, 90, 100, 110, 120. So these numbers here aren't going to line up to the values of your X variable. That's the only kind of downfall of this like prediction, this margins command, right? It'll basically, the number it's telling you is this is the iterations. You kind of have to remember, okay, where did it start out? And there's some other tricks you can do, but I'm not going to push you that far. But you have to kind of remember where it like started out and kind of what your increments were. So remember we said the turning point for the marginal effect of unemployment was like 139,000, I think was the income value we said. We'll notice here, so if we start at 50, 60, 70, 80, 90, 100, 110, 120, 130. So at 130,000, the marginal effect is still negative. Once we get to 140,000, we've passed that turning point. Now the marginal effect of unemployment at that income level of 140,000 is now positive. So you can kind of get an idea about where that turning point is at using that margins command, but you can find the precise value, probably what's a little bit better is using like that display and using those stored coefficients. Questions over anything that we've talked about, or what if I did this, or what if I did that? Okay. All right. So let me think if there's anything else that I haven't said yet. I think I should cover it for the material here. We'll jump into the next topic next Tuesday, the 4 or 5 days from now. And I mentioned, maybe I mentioned in class, things are running together today, but I will likely be at the hospital Thursday. So you'll likely have a video that kind of extends wherever we stop on a Tuesday, kind of leading into Thursday's class. I'll likely get the next assignment posted either this afternoon or tomorrow morning. Do not feel like you have to start working on it. You can if you want. It'll have a bunch of the it'll have a bunch of the interaction term stuff, but it's also gonna have some questions at the end over the material we cover next week. So you can get started on it, but you likely won't be able to work through the entire thing. So I might get that problem set up. I'm not gonna post the quiz because the quiz will have some questions over what we cover next week. I don't want someone to like accidentally start it and be like, well, I didn't know, we haven't covered this yet. So the quiz won't pop up, but the next problem set might. The due date will be quite a bit out in the future. But if you want to get an early start on it, it does go over interaction stuff. And so we just covered that. You can kind of start working on that, getting that out of the way. But you do have that fourth problem set and quiz due at the end of the day tomorrow. So I would focus a little bit more on those first if you haven't gotten those completed. Okay. Other than that, I think that should do it for me. So if there's no other questions. All right. So I'll get an announcement posted about. I'll be there tomorrow, 10 to 1:30 in my office if you want to have last minute questions. Other than that, have a fun, safe weekend. We'll see you guys on Tuesday.